In this video we are going to discuss a strategy for modeling free flow through a surface using soft terrain hydrology tools rather than using hydro enforcement, which forces flow in the direction of a feature. So with this we have a quick example here where I've got a surface, I have my culvert, and if I don't consider the culvert, my flow is not going to go where I'd like. So let's start out by modeling this without any hydro enforcement or consideration for free flow. So I'm running the streams and ponds tool. We can see, well, with this, without having that as a hydro enforced feature, my water ponds on the upstream side and flows down the ditch before crossing the road. Now, in the vast majority of cases, the easiest thing to do here is to use a hydro enforcement feature, where we can select the feature that we'd like to act as a culvert, or it could be a pump setup where we're pumping water uphill, or a bridge that's included in our surface. So we're going to turn on the hydro enforcement property of this feature that we'd like to represent our culvert. We'll hit apply, and we'll remodel that streams and ponds. And there we go. We can see the flow now follows the path we'd like. Now with this, hydro enforcement features have a direction associated with them. So if I were to check the direction of this feature, well, I can use my arrow key, buttons down here. I can see it runs up that way. Now it's a little nicer visual for others to see here. We can also use an arrow to describe that, so we can see the feature goes this way. And with that, the hydro enforcement feature key word within a word there is the force part, where we can force this to go uphill or go anywhere that we'd like. So I can move this over here. I can rerun that streams and ponds tool, and we can see it's going wherever that arrow points. I'm going to hit undo. And one key consideration there is you're going to want to be cognizant of the direction of your features. Now, if this was pointed in the wrong direction, we could right-click, modify, reverse our feature to deal with it. So that is an overview of how hydro enforcement works, but there are cases where you may want to actually model free flow. And with this, the enforcement functionality is nice for a number of reasons. One, if you're dealing with an example like this, it's pretty clear what way the water should go. So we can just throw in a feature and not have to worry about it. Two, if we had a case where we wanted to move water uphill, again, the hydro enforcement functionality addresses that. And then three, if you're dealing with surface imperfections, maybe you're dealing with remote sense data like LiDAR data and there's a gap and a bad triangle, well, rather than having to go through and modify the surface to get the behavior you'd like, you can throw in this hydro enforcement feature and deal with those imperfections quite easily. So what is the case where you might want to use a free flow example? If you have a situation where you are unsure what way the water is going to flow, you can modify your surface and not force the water through, but just have the surface act as a normal surface without the barrier, in this case the road, in the way. So with that, first I'm going to do something that's going to not give desirable results. So I'm going to turn this hydro enforcement feature off. I'm going to just turn this into a modeled break line feature. I'm going to hit apply. So right now, if I remodel my surface, we'll have a look at what this looks like. And we can see, well, we've got this really narrow trench running through there. And if I rerun my streams and ponds tool, now we're going to take note that I'm using a cell size of 2. If I rerun my Streams and Ponds tool, it's not capturing what I'd actually like to capture. And, well, why is that? And that is because the hydrology tools, most of the software uses a tin surface. The hydrology tools use a raster or a gridded surface, and we want to be cognizant of that cell size. So in this case, the surface that the tool is considering isn't the surface that we're seeing. It's going to be something that looks like this, where we have those individual cells kind of acting as blocks. The grid function samples the tin elevation at the grid spacing, and since that trench was so narrow, at this point, this point, this point, and up here, it's sampling elevations that are not in the trench, but just off to the side of it. So how do we deal with that? It's pretty straightforward. We are going to deal with it with a quick workflow. So one, I'm going to take this culvert feature that we're using. I'm going to just minimize some files. I'm going to bring it back into another terrain file. I'm going to paste that feature in here. I'm going to modify this feature by buffering it. Here I'm going to modify both sides. I'm going to buffer it based off our cell size. I'm going to close the feature. Whoops. Actually, rather than close, I'm going to join the feature first. Modify, join. I'm going to make this outer buffer a tin boundary. I'm going to just turn off my symbol here so it's a little easier to see. We're going to modify a surface from this buffer, or create a surface from this buffer. So we're going to generate our tin. And this is the trench bottom that we're going to consider. So we're going to save this. Trench bottom. We are going to go back into our surface here. We are going to click merge. We are going to merge in that trench bottom surface that we've just created. We'll hit OK. We'll hit OK. We're going to remodel our tin surface so it's up to date. And there we are. So we've got this wider trench bottom. And now when we run the Streams and Ponds tool, we can see there's no blocks through that, and it gives us the desired results. And what does that surface look like from a software perspective as it's considering those paths? Well, here, since we have that buffer greater than our cell width, we can see, well, this is the series of steps the surface considers. And there's no blocks here, so it runs right where we'd like it to run. That's that.